Welcome back to Carnes Studios. I hope you enjoy my learning environment here. I have actually two topics to share with you today. The first one, which I'm going to do right now, directly connects to the last thing you learned from Mr. Kleinhans, which was this, all right? You learned from Mr. Kleinhans that if you have two tangents to a circle, remember a tangent just skims a circle in one point, if they cross outside the circle, then to find that angle that is formed, so I called it angle 1 right here, remember you subtract the big arc, I did it in red, minus the small arc, and cut that in half, all right? So again, subtract the big arc minus the small arc and cut it in half. That'll get you that angle. But what happens if instead of tangent, they're secant? And if you forgot, the word secant, remember, means that it cuts through in two or more spots. So it doesn't just skim the circle, it actually cuts right through the circle. Well, what happens? Good news for you. It's the same thing. You take 1/2 of the two arcs that are created by that. So again, I made those red, and you subtract those two. It's just like what you learned before, except this time the arcs don't take up the whole circle. The intercepted arcs, that's what they're actually called, would just be these two right here. So again, you take 1/2, the bigger intercepted arc minus the smaller intercepted arc, and you will get angle 1. One more example up top, and then I'll actually do some real examples. What if you have kind of a combo of the two? What if you have one that's tangent, but the other one is secant? It's the same thing. If you follow the angle, if you follow these rays right here, and you find where they cut through the circle, those two arcs are the ones you subtract and then cut in half. Notice, this arc down here, BA, has nothing to do with the two that cut through the circle, all right? So that's why we don't include that. That's not part of the intercepted arcs, only the two in red right here, okay? The more of these you do, the more you'll get used to looking out for that, okay? But let me do a couple quick examples, all right? Number one, if I were you, I would definitely take some notes here on this, write these down. These will help you with your assignment tonight. Number one, we have kind of what I have in picture 3 up there. We have a tangent, it looks like, and a secant. And actually, I have the angle, but I have to find this arc right here. I'm a huge formula person, meaning if there's a formula for something, jot that down first and then plug numbers in. All right, so right here, I'm gonna write the formula down. Okay, the formula says that the angle, so it's not angle 1 anymore, I actually know the angle, 31, has to be 1/2 of the two arcs subtracted. So the bigger one is 168, and this time the smaller one is actually the unknown x, okay? Now, there's a couple ways you could do this. Some of you are probably gonna wanna distribute that half with both numbers. I think that's messy. Here's what I would do first. You could get rid of this half by multiplying both sides by 2 right now. And when you double the left side, you get 62. And when you double the right side, that half basically cancels out and you're just left with 168 minus x. So again, all I did there was multiplied by 2, okay? And now I think you can do the arithmetic from there. If you bring the 168 over with the 62 and then get rid of the negative, you finally get 106. Okay? Any questions on that? I'm so used to teaching a class that I just asked if there's any questions to a camera in an empty room. Something wrong with me here. Sorry about that. If you do have a question, I'm sure you can email your teacher. All right, one other thing. What if I were to add a y up there? What would you have to do now? Well, now that we know the 106, so I'm gonna go ahead and fill that in. Now it's a matter of, hey, a whole circle is 360, so if you subtract 360 minus 168 and 106, let me kind of do it off to the side here, 360 minus the 106 and the 168. Y ends up being, and I'm going to cheat a little bit, 86 degrees. So there's Y. Okay, so hopefully that made sense. We're using these properties you learned right up here. Okay, let me do the other one real quick. Or better yet, what might be smart, as I erase and create a little room here, might be smart for you to go ahead and try number 2 on your own. Maybe pause this video for a second, try number 2, see what you come up with, and then I'll go ahead and reveal the answer. Okay, of course, I'm going to keep recording, so hopefully you just paused it. Let's take a look. Now, there's a lot going on here. So first of all, we have 2 tangents. So we have this picture right here. We have what Mr. Kleinens talked about the other day. One of those other properties that I've sort of skipped over is that if you have 2 tangents that skim a circle, those 2 pieces are the same length. So real simple is to get K. K is 5. That didn't really take much. Okay? I just said K, no pun intended. All right, now we have some other things, okay? Here's another one that some people may not catch. An entire circle is 360. Well, we know that this much of it is 218. From there to there is 218. Well, N is the other part of the circle. So let's just take 360 minus the 218. And now we can get N, which comes out to, again, I'm going to cheat because I did this ahead of time, comes out to 142. Okay? And I'm going to go ahead and put that in. That'll help us in our last part. And finally, what do we have? We have the new property from today. Looks like this picture here. If you need the angle, you take half of the 2 intercepted arcs that are created by those rays, you take half of those and subtract them. Okay, so 1/2 of 218 minus 142. And again, you know how to do the arithmetic there. You can distribute the half, or actually, better yet, let's do order of operations. Let's subtract those first. And so if you do, that'd be half of 76. And of course, running out of space there, half of 76, of course, is 38 degrees. Okay, so that's kind of a lot. Now, there's one more example that relates that you're not going to probably see quite as much of, but it actually could pop up. So I'm going to go ahead and show you one more really quickly here. I obviously ran out of space. So let me just quickly put this up here. And I didn't want to clutter your brains with this other one because it's sort of the oddball. All right, but here it is. What happens if you have a circle and instead of the 2, let's call them secants, instead of the 2 secants crossing outside, what if they crisscross inside? Okay, and you have to find, let's call it angle 1 again. You have to find angle 1, and let me give you some measures here. The intercepted arc, if you follow angle 1 out this way, looks like it would be this right here. So let me make up a number. Let's say it's, let's go with 40 degrees, okay? And the intercepted arc on the other side of that would be this one right here. So let's say that that's 28 degrees, okay? And you have to solve for angle 1. Guess what? Because they don't meet on the outside and instead they meet on the inside, you're gonna do everything the same, but you're not gonna subtract, you're gonna add, all right? So if I want angle 1, it's actually gonna be a half again, so that's the good news. It's the same pattern, but because they crisscross on the inside, you actually add the 2 intercepted arcs. And if you add those together, that'd be half of 68, which is going to end up being 34 degrees. okay? Now, had I wanted the angle here instead of there, then I would have been talking about these two angles, and I would have been talking about this bottom and this top, okay? But in this example, I needed the angle there, so I'm talking those two intercepted arcs. I used to tell my students that when they crisscross on the inside, it's almost like you have a plus sign inside of your circle, although that doesn't work so well here. It almost looks more like multiplication. But if that helps you to remember that inside looks like a cross and that's when you add, then so be it. But the main gist, when they cross on the outside, it's half of the two arcs subtracted. I hope that makes sense. Have a good one.